Have you ever stopped to think about those huge unseen forces in the atmosphere? How they're sort of quietly orchestrating the path of something as massive as a hurricane, even when it's days away?
It really is humbling
Mm.
how fast these things can go from just, a blip on the map to something demanding immediate attention, a real reminder of the planet's power.
Yeah, exactly.
You know?
So today we're doing one of our deep dives. We're looking at the latest on Hurricane Erin.
The first official hurricane of the 2025 Atlantic season.
Right, and we want to cut through all the noise, the constant updates, and just get to the core stuff, what you actually need to know about this storm right now.
hmm And that's really our mission here. We're trying to pull out the key bits of information from the latest expert forecast for Erin.
So you can understand its status, where it might be headed, what it means right now.
Exactly. Without getting totally lost in the technical weeds, it's about getting a clearer picture of how these big, complex systems work,
Mm.
right? And maybe appreciate, well, the world around us a bit more.
And we're basing this on a really solid, concise forecast document. It's packed with data.
It is. It's our foundation for this discussion.
So, okay, let's unpack this. Where do we start?
Maybe with the basics. What is Hurricane Erin at this moment?
Good idea. Okay, the absolute latest is that Erin is officially a Category 1 hurricane.
Right.
We're seeing sustained winds around 85 miles per hour. That's about 137 kilometers per hour.
Okay. And location?
Location-wise, it's way out there. Central Atlantic, pretty far east of the Caribbean islands.
So no immediate land worries there.
Not immediately, no. And it's currently moving northwest. Speed is about 12 miles per hour, or 19 kilometers per hour. That's the snapshot.
Yeah, and what's really striking, I think, is just how precise those measurements are, even for a storm that's so far from land.
Right. How do they even do that?
Well, it's amazing satellite tech and modeling, mostly, but it gives us this incredibly valuable starting point. And, when we hear Category 1, sometimes people think, oh, that's the lowest level,
Mm-hmm.
weakest category.
Yeah.
But 85-mile-per-hour winds, I mean, that's serious force. Think about it. That's easily enough power to damage buildings, definitely take down big tree limbs, knock out power.
Yeah, it's definitely not something to shrug off, even at Cat 1.
Not at all. And its location, right now, Central Atlantic, far east of the Caribbean, that's key context.
Meaning it's not an immediate threat?
Exactly. It tells us there's no direct danger to major land areas right now. And that distance, well, it buys us time.
Time for what? More monitoring.
Time for monitoring, yes, but also for the forecast models to run, to refine the predictions. And, crucially, time for people in potentially affected areas to prepare if the path changes down the line.
That makes sense. The fact they can pinpoint its speed, direction, intensity, all while it's just this swirling thing way out in the ocean.
It really shows how far the science has come, understanding and trying to anticipate nature's power.
Okay, so that's Erin now. Powerful but distant. But the big question always is what happens next. What are the forecasts saying about its path?
Right, this is where it gets, more complex. The models suggest it might strengthen a little bit more
Or what time frame?
over the next 48 hours or so. So while it's a Cat 1 now, it could perhaps get a bit stronger within that category, maybe even nudge towards Category 2 briefly.
Okay, potentially strengthening. But the landfall question, is it heading for land?
Well, the good news, at least for the next few days, is that it's not expected to make landfall.
Okay, good.
But, and this is really important, but from the forecasters, the long-term path, that could absolutely shift.
Ah, so it's not a sure thing it stays out at sea.
No, definitely not. It's not like it's on railway tracks. There are these huge invisible forces in the atmosphere that are basically going to steer it.
And those forces can change.
They can, and predicting how they'll interact with the storm is the real challenge.
So what are these big steering forces? What actually pushes a hurricane around?
That's really the core of hurricane forecasting, isn't it? It connects to the bigger picture of atmospheric steering. It's less about the storm's own engine, its internal power, and more about these massive currents it gets caught in.
Like currents in an ocean?
Sort of, yeah, but in the air. Think of two main players, especially in the Atlantic.
Okay.
First, there's usually a big Atlantic high-pressure system.
Hmm.
Imagine a huge dome of stable, heavy air sitting over the ocean.
Okay, like a giant invisible mountain.
Kind of. It often acts like a barrier, a wall. Storms tend to get deflected around it, maybe pushed south or steered westwards along its edge.
Got it. High pressure pushes it away. What's the second player?
The second one is the possibility of troughs, areas of low pressure, sometimes setting up near the U.S. East Coast.
So the opposite of the high pressure.
Exactly. A trough is more like an elongated valley of lower pressure. Instead of pushing a storm away, a trough can kind of pull it or create a channel that draws the storm towards it, often north or northeast.
Ah, so it's the push and pull between this big high-pressure wall and any low-pressure valleys that might form.
Precisely. It's this constant dynamic interaction between the dominant high and any troughs that develop or fade away. That's what ultimately steers a storm like Erin. Forecasters are watching these larger systems just as closely as the hurricane itself.
Wow. It sounds like an atmospheric ballet almost.
It really is. And that's why forecasting isn't just about the storm. It's about understanding this whole huge environment it's moving through. It's why there's always that uncertainty in the longer range forecasts.
Okay, so bringing this back down to Earth, what does this all mean for people on land right now? You said no landfall expected soon.
Right. And importantly, as of the latest forecast, there are no coastal watches or warnings in effect for any land areas.
That sounds significant. What does that specifically signal in terms of preparedness?
It signals we're still very much in the monitoring phase, not the action phase.
Yeah.
We have this tiered warning system for a reason.
Right. The watches and warnings mean different levels of threat.
Exactly. So the National Hurricane Center, other agencies, they're tracking Erin incredibly closely, but they aren't yet telling communities, you need to take protective action now.
Because the threat isn't imminent or certain for any specific place yet.
Precisely. It gives everyone time. Time for the models to update with new data, maybe from hurricane hunter planes, and for the forecasts to get more refined. It's actually a sign of how sophisticated forecasting has become. We can track a powerful storm from afar without triggering widespread action until it's truly necessary for specific areas.
It allows for a more measured response.
Yes, exactly. Informed and phased.
Okay, but you mentioned something earlier. Swells. Is that an immediate risk?
Yes, that's the one thing mentioned as a more immediate, though indirect risk. Even though Erin is far away, its powerful winds are churning up the ocean surface.
Generating big waves?
Very big waves, or swells. And these swells can travel huge distances across the ocean, way faster and further than the storm itself.
So they can arrive long before the storm gets anywhere near.
That's right. And the forecast specifically mentions that these swells generated by Erin could start affecting Bermuda by early next week.
So even if Bermuda doesn't get the wind and rain directly, the ocean conditions will get rough.
Definitely. Dangerous surf, rip currents, that sort of thing. It's a really good reminder that a hurricane's influence extends far beyond its center.
But that connection across the ocean.
Absolutely. That early heads up about swells for Bermuda really highlights it. It also brings up an important point about how forecasting helps prepare us even for these distant impacts.
Like for sailors or coastal areas?
Yes, mariners, anyone on the coast, even beachgoers need to be aware. These swells aren't just local waves, they're energy moving across the whole ocean basin. They can arrive when the sky overhead is perfectly clear.
A subtle warning from far away.
Yeah. It lets people take precautions well in advance. It just reinforces that weather science is about these huge, interconnected systems, atmospheric and oceanic. It's a constantly evolving understanding.
Okay, let's try and pull this together then. The key takeaways from our deep dive on Hurricane Erin, the first hurricane of 2025.
Okay.
First, it's a Category 1 storm. It's out in the central Atlantic for now, not an immediate land threat.
Check. Moving northwest? Might strengthen a bit in the next couple of days.
Right. And the really crucial part, its long-term path isn't set in stone. It depends heavily on those bigger atmospheric steering currents.
It's that interplay between the Atlantic high and any potential troughs near the U.S. coast. That's the key uncertainty.
And for now, importantly, no coastal watches or warnings are up.
Correct. But that one exception, keep an eye on Bermuda for those ocean swells starting early next week.
Got it. So why is digging into these details, beyond just the headline Cat 1 storm forms, actually valuable for people listening?
Well, I think understand the why behind it all, like why the path is uncertain, understanding the role of that high pressure in those troughs, it gives you a much richer appreciation for just how complex nature is.
And the science trying to predict it?
And the incredible science, it moves you beyond just hearing a category number to actually grasping the forces involved, this huge atmospheric dance that the meteorologists are trying to figure out.
It connects the dots.
It really does. You start to see the connections, often invisible, that shape our world. And you appreciate the effort going into decoding it all, trying to keep us safe and informed.
So maybe a final thought to leave people with. Next time you see one of those forecast cones, that projected path for a distant storm, Maybe take a second to think about those invisible giants, the high pressure systems, the far off troughs that are silently shaping that path days in advance, hundreds or thousands of miles away.
Yeah. What does that tell you about how interconnected everything is on our planet?
And maybe how much more there is still to learn about the air we breathe and the oceans that surround us.
Always more to discover.